Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Zalfa Salmaihdah. Today, I would like to present a topic entitled Fibonacci and the golden ratio, the magical numbers. This presentation explains how mathematics exists not only as number and formula, but also in nature, art, and architecture. Okay, let's get started. Fibonacci and the golden ratio, the magical number. What is the Fibonacci? Fibonacci is a sequence of numbers where each number is the sum of the two preceding numbers. The sequence is usually written as 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, and each other. Mathematically, the Fibonacci sequence is formulated as Fn equals Fn minus 1 plus Fn minus 2 for n greater than 1. The Fibonacci sequence is interesting because the ratio of two consecutive numbers approaches the golden ratio. P is approximately 1.618. The pattern is found in nature, such as in the arrangement of flower petals, the spiral of sunflower seed, and the growth of leaf. A brief history of Fibonacci. The Fibonacci sequence did not originally come from Europe, around 300 before Christ. An ancient Indian mathematician and Putnam Acharya Pingala described a similar numerical pattern while studying syllable patterns in Sanskrit poetry. This early form of the sequence was known as Matrameru. The sequence was later introduced to Europe by Leonardo Fibonacci, commonly known as Fibonacci and Italian mathematics of the 13th century. In 1202, he described the sequence in his book Liber Abaci through a famous example known as the rabbit problems, which model the growth of a rabbit population over time. Through Liber Abaci, Fibonacci also played a key role in popularizing the Hindu-Arabic numeral system in Europe, replacing the least efficient Roman numeral system. Because of Fibonacci's influence and contribution, the sequence became widely known as the Fibonacci sequence. The relationship between the Fibonacci sequence and the golden ratio. The Fibonacci sequence is closely connected to the golden ratio. This relationship became clear when two consecutive Fibonacci numbers are divided. The resulting values are not random, but gradually approach a specific numbers. For example, 8 divided by 5 equals 1.6. 13 divided by 8 equals 1.625. 21 divided by 13 is approximately 1.615. As large Fibonacci numbers are used, the ratio gets closer to 1.618, which is the value of the golden ratio or P. The difference between the ratio and P becomes smaller as the sequence continues. However, this ratio never equals P exactly because the golden ratio isn't an irrational number. They demonstrate how the golden ratio naturally emerged from the Fibonacci sequence. What is the golden ratio? The golden ratio, represented by the Greek letter P, is a special number that describes a perfectly balanced proportion. Its approximate value is P is approximately 1.61803398. The golden ratio is classified as an irrational number, meaning it cannot be expressed as a simple fraction and its decimal expansion continues eventually without repeating. The golden ratio appears when the ratio of a large quantity to a smaller One is the same as the ratio of the whole to the large part. This unique relationship creates a sense of harmony and balance, which is why the golden ratio is often associated with beauty and aesthetic appeal. The concept of the golden ratio. The line segments image present the fundamental mathematical definition of the golden ratio. A line is divided into two parts. A long segment is A and a short segment is B. The division follows the golden ratio if the following relationship holds. A over B equals A plus B over A equals 1 plus the square root of 5 over 2, approximately 1.61x. This means that the ratio of the longer part to the shorter part is equal to the ratio of the whole line to the longer part. This proportional relationship creates balance and harmony. The concept of the golden ratio. From this golden ratio relationship, golden rectangle can be constructed. The rectangle can be subdivided into squares whose side lengths follow the Fibonacci numbers 2, 3, 5, 8, 13, 21, 34, and so on. By drawing quarter-circular arcs inside each square, these arcs connect smoothly to form a Fibonacci spiral, which represent natural growth patterns commonly seen in natura. Fibonacci pattern in flower petals. Many flowers display Fibonacci patterns in the spiral arrangement of their petals, growing at the golden angle of about 137.5 degrees. The petals are evenly spaced without overlapping, and white pollinators tower at the center. The number of petals often match Fibonacci numbers such as 3, 5, 8, or 13, showing the connection between mathematics and natural growth. Fibonacci pattern in sunflowers. Sunflowers clearly display Fibonacci sequence through their spiral patterns. The seeds form two interlocking spirals rotating in opposite direction, with the number of spirals often matching Fibonacci numbers such as 34 and 55 or 55 and 89. The spiral arrangement, pointed by the golden angle of about 137.5 degrees, allow efficient and orderly seed packing. Golden ratio in architecture. One of the famous examples of the golden ratio in architecture is the Parthenon in Andes, Greece. Its facade proportions are often likened to P 1.61x, especially in the relationship between width, height, and column spacing. This use of the golden ratio creates balance and harmony, showing how mathematics principles contribute to lasting architectural beauty. Fibonacci and golden ratio in art. The golden ratio and Fibonacci sequence are widely used in art to create balance and harmony. Artists use the golden ratio to place key elements so they look natural and proportional. A famous example is Mona Lisa by Leonardo da Vinci, whose facial and body proportional are often likened to the golden ratio. In modern art and design, Fibonacci spirals are also used to guide the viewer's eye toward the main focus of an artwork. Conclusion. The Fibonacci sequence and the golden ratio show that mathematics is not just a collection of numbers, but a pattern that shapes both nature and human creation. These patterns can be seen in many forms, from flower petals and sunflower spirals to works of art and architecture. Their presence creates balance, harmony, and efficiency in structure and design. Therefore, the Fibonacci sequence and the golden ratio are often called magic numbers, not because they are mystical, but because they reveal the hidden order and beauty within mathematics, nature, art, and everyday life. That is all for me. If there are any words that were not pleasant, I sincerely apologize. Finally, thank you. Wassalamualaikum warahmatullahi wabarakatuh. See you.